Welcome back to Connect and Transform. In this video, we're going to be writing a regex to validate and match strong passwords. We're going to be using the tool at regexpal.com, not related to me. I'm just using it because it's a convenient way to put in a regular expression and then to test a number of inputs such as A, B, C, D, 1, 2, 3, 4, etc. We're also going to be using it as a notepad for our notes, which I just pasted in there. We'll come back to that. I'm going to look over here at the flags. Because we're dealing with strong passwords, we know we're going to differentiate between lowercase letter characters and uppercase letter characters. So we do not want to ignore casing matters. So I've turned off the ignore case flag. For the purpose of demonstration, I've enabled the global flag and the multi-line flag, but depending on your implementation, these two flags may not be necessary. So let's look real quick at our assumptions and requirements or definitions. Our one assumption is that our passwords do not allow new line characters. The reason for this is that it was a simple compromise because the dot symbol in regular expression syntax in its normal form represents any single character except a new line character. So just for the sake of sanity and simplicity, I'm sacrificing the new line character from being allowed in a password. I think it's a reasonable compromise because a password can still contain any other character and it can be as long as you allow it to be in the regex. So let's look at an example of requirements or definition for a strong password. So you might say that you're requiring one or more lowercase letter character, one or more uppercase letter character, one or more numeric or digit character. And then you might also require other characters, special characters, which will mean anything that is not in one of these three character classes, keeping in mind that it must also not be a new line character in this case. And then you might also enforce that the length should be 8 or more. Because this is a password, we're going to be looking at the whole string. We're not just going to be looking at part of the string. So we're going to use some regex syntax, caret and $, which represent the beginning of the string and the ending of the string. And just to start out with a very simple regex, we're going to say dot plus. And so what that does is the dot matches anything except a line break, and the plus says there must be one or more of them. So we're not going to accept an empty line, but here, if you can see where my cursor is, this is a tab character. So even though it was invisible to us, there is information there, and so that technically matches the regex of dot plus. Anything that's highlighted in blue here matches. Anything that is not highlighted, like empty lines, is not a match to our regex. So let's look at our first requirement. One or more lowercase letter characters. They could be anywhere in the string, beginning, middle, end. The string could be comprised entirely of lowercase letter characters or partially. We're going to use a construct called positive lookahead. And so we're going to say that there could be any number of non-new line characters, even 0, before the lowercase letter character. And so we're going to be looking for a lowercase letter character. So we're going to provide a character set and we're going to provide the range lowercase a through lowercase z. And so we'll notice that 1, 2, 3, 4 is no longer selected. It's no longer a match because it does not contain A through Z. But if we were to add lowercase a, now that's a match. If we were to add lowercase j, now it's a match. If we add a lowercase character at the end, it matches. Middle, it matches. Beginning, it matches. And we can see here from ABCD that if it's comprised entirely of lowercase characters, it matches. And we can see from here, strong password, that if only part of the string is lowercase characters, it still matches. Okay, so let's copy this positive lookahead. And let's do the same thing, but for uppercase characters. So A to Z. And now we see that a lot less of them match. Like this line here, for example, doesn't contain any uppercase letter characters. So let's add one. Capital X at the end. Now that is an acceptable strong password according to the regex. So let's look at adding the requirement for one or more special character. Oh, I'm getting ahead of myself. Let's add a third positive look ahead for 0 through 9. And we see that there's not a single one of these that has a lowercase letter, an uppercase letter, and a digit character all in the same line. But if I were to capitalize that word, now this line is a match. And if I were to put a 0 on the end there, now that one matches. Okay, now let's add an additional positive look ahead for the other or special character. So to do that, we're going to use a negated set. So we're going to say that we're looking for something that matches the character set that is the opposite, the negated set. So to do that, we use the caret symbol as the very first symbol in a set of brackets. And then we're going to provide characters or one or more ranges. So we're going to say lowercase a to lowercase z, uppercase a to uppercase z, 0 to 9. But then we also have to remember, we don't want to match any line breaks. So we also have to add in rn. And so now this negated set will match any character that is not a line break or a lowercase letter character, uppercase letter character, or a digit character. And so now we see strong password 0 matches, and you might be wondering, well, where's the special character? Well, it's the space between the words strong and password. And then there's plenty of special characters here. There's white space, there's a hyphen. And so, for example, here, what is this line missing? Well, this one's missing a digit character. So if we add a 1, now that matches. If we were to create the simplest password, let's say it's lowercase a, uppercase a, letter 1, and the symbol special character exclamation, well, now it matches. So let's look now at our last definition, which is length 8 or more. Well, in that case, instead of using the plus symbol, which says one or more of the preceding tokens, we're going to define the length as being 8 with no bound to the upper limit. Or if we wanted to say we want the password to be at least 16 characters, we would do that. And let's say we have a limitation. Let's say we're storing this password in a database, or we're storing the result of the password in the database. And let's say we know that the password cannot be any longer than let's say 20 characters. We would define it like that. So if I were to give a password here, if I were to say AA1 exclamation point, so that's 4 characters, and then I'm going to copy that 4 times. So we have 16 total characters. So 16 matches, it's there in blue. If I were to subtract 1 character, it wouldn't be long enough. Okay, so right now we have 15 characters. Right here, we're not matching. So now we have 16 and we're okay. 17, 18, 19, 20, we're still okay. But now if I add another character, 21, well, it no longer matches. The password is no longer valid because it's too long. But if I remove this, or if I increase the 20, it's now valid again. So here we have it. I'm going to paste it in there. And the curious thing is that the regex itself is a valid password according to that regex, because the regex itself contains lowercase letter characters, uppercase letter characters, digit characters, and other characters. And it is at least 16 characters long in this case, which is the current state of our strong password regex. So I'm not telling you to use a regex as your password, but it is possible. Thanks for watching.